The limit test, LIM, and the mask comparison for equal, MEQ, both require three parameters. The LIM instruction determines if a value is within the limit range as defined by the other two values. The MEQ determines if the parts of two values defined by the ones in the mask are equal. If the value of the low limit is less than the value of the high limit, the instruction will be true if the test value is greater than or equal to the low limit and less than or equal to the high limit. The instruction will be false if the test value is less than the low limit or greater than the high limit. The value of the low limit, 25, is less than the value of the high limit, 50. The test value in N7:23. Its initial value is 48. Since 48 is between the limits of 25 and 50, the instruction is true and PL1 will be on. Changing the values of N7:23 will change the status of the instruction. If the value of the low limit is greater than the value of the high limit, the LIM instruction behaves opposite to the way it behaved when the value of the low limit was less than the value of the high limit. The instruction will be true if the value of test is less than or equal to the value of the low limit, or greater than or equal to the value of the high limit. In the simulation, the low limit is 100 and the high limit is 50. N7:29 is the address of the test value. Changing the value of N7:29 will change the state of the LIM instruction and the output PL1. ControlLogix also has a LIM instruction. In this example, the value of the low limit is 6 and the value of the high limit is 12. The test value is the accumulated value of the counter, whose address is counter_range.acc. As the accumulated value of the counter is incremented, the instruction will be true when the accumulated value is greater than or equal to 6 and less than or equal to 12, and false at all other times. The MEQ instruction determines if the parts of two values defined by the ones in the mask are equal. If they are equal, the instruction is true and output PL1 will be on. In this example, the mask has all ones except for the rightmost 4 bits, which are zeros. If all of the other 12 bits are the same, the instruction will be true, and it will not matter what the least significant 4 bits are. There are no other conditional inputs on the rung with the mask equal, so when the MEQ is true, the output O:2/0 will be on. The mask has a decimal value of 65,520. It is much easier to see the effect of the mask by looking at the binary representation in the integer table. It is also easier to see in the integer table that N7:5 and N7:10 are equal in all bit positions, where N7:6 the mask is a 1. If we change a single bit in N7:10, In one of the positions where there is a 1 in N7:6, the instruction will be false and the output will be turned off.